Mr. Wiles, I'm recording the session. Just a very short introduction. Dear audience, dear students, dear lecturers, in the name of Faculty of Architecture and Design, I want to welcome you to our fourth ArchiDesign talk. And this is our last talk about timber for this semester. Our guest is Roderick Wiles, Regional Director of, American Hardwood Export Council. So our faculty member, Forestry Industry Engineer Demet Sürücü will support us as moderator. So, dear Demet Sürücü, I leave the word to you.
Thank you, Elif Hocam. Dear audience and dear academicians and dear students, good evening to all. I would like to say warm welcome to our speaker, Rod, because he is in Dubai and the weather is warm, I think, there. And I know Roderick more than 15 years, I think, but I want to give some information about who is Roderick. Roderick Wiles is a Dubai-based regional director for the American Hardwood Export Council, which is the leading international trade association for the American hardwood industry, representing the committed exporter among hardwood companies who now market and sell their products in significant volumes all around the world. For more than 30 years, American Hardwood Export Council has been at the forefront of the international wood promotion, successfully building a distinctive and creative brand for American hardwoods. By recognizing the key role design plays in successful and innovative use of hardwoods, American Hardwood Export Council helps to the American hardwood industry develop new opportunities by building a rapport with the global design community. This evening, Roderick will share his knowledge about American Hardwood Council and knowledge about sustainable management, forest management in American forest, United States forest, and he will share some major species and applications with American hardwood and new technologies with using American hardwood species and some examples he will share with us. Okay, word is yours, Roderick.
Thank you very much, Demet. Now let's just make sure this works. Okay. And can you see my screen? Can you see the presentation?
Yes.
Yes. Okay. And it's in full screen, is it?
No.
No. Okay. Just one moment. Come on. And how about now?
Yeah, that's okay.
Perfect. Perfect. Okay. Okay. Well, thank you very much for inviting me to take part in these timber talks, and thank you very much as well for the warm welcome, the kind words, and the introduction to who I am and to the American Hardwood Export Council. A lot of words, American Hardwood Export Council. So from now on, I will just refer to it as AHEC, okay. Which hopefully is a bit simpler. Now, hopefully I can control my slideshow. Okay, so the first thing I need to do is, has that moved on? Yes, you can see the new slide. Yes, okay. The first thing I need to do is explain what AHEC is. So it's a non-profit trade association. We are not dealers or exporters in wood. We don't get involved in the business of exporting wood at all. We're just a promotional organization, marketing organization, and what we do is a lot of education, and we work with a lot of architects and designers around the world in creative collaborations. And also we spend a lot of time championing the environmental credentials of American hardwoods. And that's a complicated thing to do. And I'm going to cover that subject now, hopefully without confusing too many of you. So this presentation is going to be in 3 parts. The first part, we're going to look at where American hardwoods come from, and then we're going to have a look at the legality and their sustainability. The second part, we'll look at some species and applications, and the final part, we'll look at some new technology which is benefiting American hardwoods and is very relevant to those who are building in or designing with timber, architects and designers around the world. So first of all, provenance, legality, sustainability. So this wonderful picture taken in the 19th century demonstrates how the American hardwood forest used to be treated. And when the first European settlers moved over to what became America, they were faced with an enormous forest on the east coast of America, and they needed that wood for everything. They needed the wood to build houses, to fuel their fires, to clear the land as well, to farm that land. So they did a very, very good job of cutting down a lot of that forest. And it ended up looking a bit like this in many places. And this picture was taken in Pennsylvania. Now, I can't say it's the same place, but it must be very close. This is what Pennsylvania looks like today. And in the space of about 70 to 100 years, all those trees grew back. And that's because they realized that they were cutting them down too quickly. And also because many of those first settlers who went to the United States, they moved further west. They moved to the Midwest where the farmland was better. So they abandoned the eastern seaboard of the United States. And the trees grew back. And this is the wonderful thing about trees. They grow back if you let them grow back. Today, this is what the forests, where the forests are in the United States. And when we're talking about hardwoods, we're talking about the eastern side, pretty much everything east of the Mississippi, all the way from Vermont in the very northeast down to Florida in the southeast and across to Texas in the middle. And what's interesting about this particular map, and this is really important, is to look at the ownership of the forest. Now, I know in Turkey, forests belong to the government, belong to the state. In America, 75% of forests belong to private individuals. And what's more amazing is that 95% of the hardwood that is harvested every year comes from private land. And these are small private landowners. They're not private companies. These are very, very small farmers with small patches of forest. This is a really important thing when we talk about sustainability, and I will explain that. And this particular slide shows a survey that's done every year in America, and they go out to all of the people who own those forests. They ask them, why do you own forest? Why do you have it? And there are 13 reasons here, and number 11 of those 13 is to produce timber. So they don't keep their forests to produce timber, they keep their forests for many, many, many other reasons. To them, it's about beauty, wildlife, water protection, hunting, recreation. Timber is just one of the many reasons for them to look after their forests. They understand its value, not just as a resource for cutting down. And here is an example. This is an old picture from 2010, but it doesn't matter. And this shows a stand of American tulip wood in Virginia that has been harvested 2 times since the 1970s and is ready to be harvested again in 2010. Now, it's not because the trees have all grown back, because they don't grow that quickly. It's because they don't clear cut them. They only remove selective individual trees and they leave other trees behind. So the forests are never completely cut down in one go. They just remove individual trees, one here, one there, one here, and those trees are then sold at auction, and all the sawmills in the local area will bid for that wood. So it's not just everything cut down and sold. It's just a few trees here and there. And some statistics for you. So the area of forest is actually increasing, and from 1953 to 2012, it increased massively by the combined, and the forest itself is a combined land area of France, Belgium, Netherlands, and Germany, or 1.5 times the size of Turkey. And this is just the hardwood forest we're talking about. We're not talking about softwoods and pine trees, it's just hardwoods. And it's rising at a big rate, 401,000 hectares per year, or adding an area the size of a football pitch every 2 minutes. And it's an interesting image, this, because we talk a lot about wood, with forests in Brazil being cut down at an alarming rate and the size of a football pitch every second disappearing. Well, in America, it's completely different. It's the opposite way around. It's also an incredibly diverse forest. And again, we're looking at the eastern side, the right-hand side of the map is where the hardwoods are. And the darker the green, the more diverse. So it's a completely natural, biodiverse forest, full of animals, full of wildlife. It's not replanted. This is naturally regenerating. This is not a plantation. It's not like a crop. These are just natural forests, which are carefully managed. And actually on our website, we have an interactive map, which is based on constantly updated data, which shows you the growth rate and the harvest rate across the United States by state, by county, of all the individual species. And if you go on there and choose a species, choose a state, you will almost be guaranteed to see that the growth rate is higher than the harvest rate. So this forest is getting bigger all the time. So we can talk about sustainability, but how do we demonstrate it? It's very difficult. Now, you've probably all heard of FSC or PEFC, this Forest Stewardship Council or Program for Endorsement of Forest Certification. These are certification schemes which prove the legality of wood products. Now, in America, it's extremely difficult to certify the forest because it belongs to over 9 million private individuals. So how do you certify it? Those schemes don't work for so many individual landowners. It just doesn't work. It's too expensive. The system isn't catered for them. So this means that the vast majority of American hardwoods are not certified. But that does not mean that they're not legal or not sustainable. So we need to demonstrate legality and sustainability in other ways. And there are 4 pillars here to do that. The first is a forestry risk assessment, which was originally commissioned in 2008 and then updated in 2017 and 2019. This looks at the risk of illegal wood being entering the business chain, if I can say, in America and being exported from America. The conclusion of this report is that less than 1% of American hardwood could be considered to be illegal. Then we have the forest inventory analysis. This is constantly updated inventory of how many trees there are, what size are those trees, what species, where are they located. This is going on all the time. There are thousands of people on the ground counting trees, and also they're using NASA satellites to count trees from space. And actually they can even determine the diameter of a tree from space now, and sometimes its species. Then we have life cycle assessment. So this is when we're talking more about sustainability, is we look at the environmental impact of cutting down these trees and exporting this wood around the world. And then all of those things, just back on life cycle assessment. And what's really interesting, again, we have on our website this tool, which is well worth looking at. This actually shows how quickly individual species are growing. So it takes 0.57 seconds for 1 cubic meter of American red oak to grow in the forest. Now, that's not because these trees are growing really quickly. It's because there is so much timber growing all the time. The volume is huge. So it's very easy. You can go onto the website and you can use this calculator. I'm sorry, the slide's jumping. And we also put life cycle assessment into practice every time we do a collaboration project with designers or architects around the world. We actually look at the full life cycle environmental impact of what it is they made. Here's a project we did in Australia some years ago, and we commissioned all of these designers to make something to sit on, and everything they made had a full environmental life cycle assessment, which was a really interesting piece of work. And the final thing that we can talk about is the American Hardwood Environmental Profile, which is actually all of these things put together in one document. And this document is something that can be provided with every shipment of American hardwood lumber that comes out of America. And what's really interesting about this document, it's an ugly document, absolutely, but what it does is this can be fed into green building rating systems around the world. So we're not just looking at legality, we're not just looking at sustainability, we're also looking at the full environmental impact of removing trees from the forest, cutting them into boards, kiln drying them, and shipping them around the world. And what's really fascinating is that American hardwoods, when they're shipped around the world, they are always arriving as carbon negative, which means that there is more carbon stored inside the wood than was emitted in all the processes of getting them there. In other words, cutting a tree down in the forest, sawing it into lumber, shipping it all the way to Australia. Yes, there are carbon dioxide emissions associated with all of those processes, but still there is more CO2 per kilogram of wood inside the wood than there was released in all of those processes. This is wonderful because as an architect, as a designer, you can then work with a material that has a really, really low environmental impact. Right, so now we're going to talk a little bit more about species and applications. America has, I think, 22 commercial species of hardwood. Again, we're only talking about hardwoods. There are many, many species of softwood as well. The dominant species are the oaks, American red oak, 18%, American white oak, 15% of the standing timber in the forest. We will look at them individually, but American red oak and American white oak are very similar in appearance. They're both oak, of course, they have very similar properties, but there are some fundamental differences. And American red oak is only available from the United States. It doesn't grow anywhere else in the world, although some has been planted in a few countries around the world, like in Germany. The other major species are soft maple and hard maple, which are very, very similar. Soft maple is slightly softer than hard maple. American tulip wood, which is a very, very unique species, also only grows in the United States. And then what's interesting is when we look at walnut, American walnut, which is a species that everybody knows and loves. It's a beautiful dark timber. It's actually not even 1% of the forest in America. But that doesn't mean that it's running out or that there isn't enough of it or that we shouldn't use it. It just means that we need to think a little bit more carefully when we're specifying timber, and maybe we should make more use of the ones that dominate the forest, like the red oak and the white oak and the other bigger species. It's important to understand that when American hardwoods are cut down, when the trees are cut down and those trees, those logs go to a sawmill and they're sawn into boards, that after they've been sawn, they are kiln dried. And without going into the details of this, this process has been perfected over many, many, many years. And kiln drying American hardwoods is always done to about 8 to 10, 11% moisture content. This is really, really important because this is when the wood becomes stable. And then it can be shipped in a container to Turkey or wherever it is around the world, and it will remain stable. It won't expand or contract, or if it does, it'll be very, very minor. And this means it is then ready to be used in a project, ready to be used in a piece of furniture, in a floor, in joinery, or something else. This is really important. American hardwood lumber is also graded very carefully. Now, there are a number of different grades, but it's all based on the appearance. So it's actually the amount of clear wood or defect-free wood that you find in a board determines the grade, and also, of course, that will determine the price. And this is done by individuals. So this man here is standing, he's individually grading every single board, he's flipping them over, he's looking at both sides of each board, and he's determining what grades they are. They are graded before they're kiln dried, and they're graded again after they're kiln dried, because sometimes some defects can occur during the kiln drying process. Again, this is very important. And as a designer, as a specifier, it is important to have not necessarily knowledge of how to grade lumber, but it is important to understand that there are different grades. You know, what are you going to make with this wood? Are you going to be making door frames? In that case, you need long, clear pieces of wood without any defects. Are you going to be making small pieces of furniture, kitchen cabinet doors? Well, you don't need long, clear pieces of wood. You can use a lower grade at a lower price, for example, with less wastage. But what's really important to understand is that the clear wood on the lower grade is the same quality as the clear wood on the higher grade. It's just there is less of it. So let's look at some species individually. So this is hard maple. This is the tree that you get maple syrup from. And the net volume is increasing by about 9.4 million cubic meters every year. So there's more hard maple tomorrow than there was today. This is a cold climate species. It grows in the north of the United States and obviously into Canada. The leaf of the maple is on the Canadian flag. It's a very white or blonde species, and it has many good properties. It can be used in joinery, in furniture, many applications, and also it's used often in sports flooring because it's really tight grained, you won't get splinters, and it's a nice clear timber and very hard as well, so it's ideal for that. Cherry. Now, there is cherry in Europe, there is cherry in Turkey, but it's not quite the same as American cherry or black cherry, which is much, much more red in the middle and has a big contrast between the heartwood and the sapwood. The sapwood is more of a yellow color. Again, there is more cherry tomorrow than there is today, although it's about 3% of the forest and grows particularly well in 1 or 2 states, not in every state. Cherry is beautiful in joinery, and here it is in paneling in a project in Australia. Something that's important to understand about cherry is that it is photosensitive, and it will, when it's exposed to ultraviolet light, it will get darker and darker over time. And it reacts very quickly. So if you have one piece near a window and another piece in the shade, those 2 pieces of wood will be very different color over a short time period. So that's important to understand as a designer. Walnut. Now, walnut, as I mentioned earlier, this is the king of American hardwoods. It's the most valuable of American hardwoods, the most expensive. It's about 1% of the forest in the United States, and it only grows in a few areas. It is an unusual one, as this particular tree tends to grow on its own. It poisons the ground around it, so it stands tall and grows on its own. There is walnut, of course, in Turkey. There's walnut in many parts of Europe, but this is American black walnut, which is slightly different. The wood is darker, although there is a very big contrast between the heartwood and the sapwood. And what they do often after sawing walnut and cherry into lumber, into sawn timber, they often steam it, which makes that color run into the sapwood so that it becomes more uniform in color. Walnut is beautiful in interior joinery and detailing and furniture. It's probably a little bit soft for flooring, although it is sometimes used as flooring. And I do come to Turkey every now and then, and I see a lot of walnut, walnut veneer in particular in restaurants and hotels and in all sorts of places. So it's a very popular species all over the world. American tulip wood. Now this is an unusual one. It's called tulip wood. It's related to the magnolia, although in America they call it poplar, but it's not poplar at all. It's just because it's a very tall, in fact it's the tallest of the American hardwood trees, and the leaves are similar to poplar leaves. This is unique to North America. It is a very, very tall tree. It grows quite quickly and it produces really large logs. It's a very light color with a dark heartwood and a lot of color variation inside. It is a very unusual species because it's extremely light, it's a little bit soft, but it has the highest strength to weight ratio of any hardwood. In other words, it can be used in structural applications, and we'll talk about that a little bit later on. Here is a project we did in Australia a few years ago, where we worked with some designers. We asked them to replace what they had made with white oak or walnut or whatever it was they had used. We said, make it again, but use American tulip wood. So they did, and it was a very interesting project because not all of them liked working with tulip wood, not all of them liked the outcome, but they found it really fascinating to learn about this different species that was extremely easy to work with and produced some very interesting results. Now, red oak. This, as I mentioned earlier, is the #1 species in the forest in America. It's about 18% of the forest in America, and it's often known as the bread and butter of American hardwoods, which means that everyone in America knows what red oak is. There will be red oak in every home in America, in a floor, in kitchen cabinets or door frames. Somewhere there will be red oak. It is a true oak, just like European oak, but it has one major difference, which is that it is porous. There are little pinholes that run all the way through, and this means that you cannot use it to store liquid. So you can't make wine barrels or whiskey barrels out of red oak. You can't make boats out of red oak. And also you need to be a little bit more careful when using red oak in exterior applications, although there are ways to get around that as well. And an interesting note, red oak, it's not red. It's called red oak because the leaves turn red in the autumn. Having said that, there is a slight pinkish tone to the timber, a little bit more pink than white oak, which is a little bit more straw colored. Red oak is extremely versatile in solid timber and also in veneer, can be used in flooring, joinery, wall panels, doors, kitchen cabinets, all sorts of applications. This was the Reba Sterling Prize winner a couple of years ago, the Bloomberg headquarters designed by Foster and Partners in London, and it's absolutely full of red oak everywhere inside this building. And it's all naturally finished, which is really beautiful because often red oak is stained or bleached, but you know, they left it alone here, so you could see the natural color and the natural grain. This is a project that took place in September in London for London Design Festival, and what we actually did was create these design posts to mark the 10 different design districts in London for the London Design Festival. And we worked with 2 architecture schools in London. So 10 recently graduated architects produced these design posts, all of them made out of red oak, and all really unique and fascinating. White oak, so this is the other oak from America. This is about 15% of the forest. It's probably the #1 species exported from the United States. It's used all over the world to make furniture, as we know, to make flooring, and also even to make windows. And in fact, American white oak is used in Turkey quite a bit to make windows by one particular company. And it is also probably the only American hardwood species that has natural durability for exterior use, but with caution, again, because as I'm sure Demet can tell you more about this than I can, but using wood outside needs to be done with a great deal of care. And it's more about design and application than actually about the wood itself. Here's a project in Australia. Australia, they absolutely love American white oak. They love it because of the shape of the grain, because Australian hardwoods are cut on the quarter, which means it's very straight grain, whereas with the American species, they're cut on the crown, they're flat sawn, so you get a really interesting grain pattern in the wood. This is something I took off the internet. I mean, it's not something I created. It's the Yanka scale, which is used to determine hardness suitability for flooring of hardwood. And the American hardwood species are not the hardest hardwoods, of course. You need to look at some of the tropical species for that. But they sit quite nicely in the middle here. And so ash, red oak, white oak, those are all highly suitable for flooring. When you go a little bit lower down into black walnut and cherry, they can be used for flooring, but not recommended in an area where there are lots and lots of people, like in a shop or something, or where there are people with high heels. So it's the sort of thing you might have at home. So this is another really important determination, is how dense, how hard is that wood. And we're going to look at some new technology for hardwoods. So first of all, wood modification. Now, funnily enough, in Turkey, the biggest wood modifiers are located. And there are 2 particular companies based in Istanbul who thermally modify hardwoods and softwoods for use outdoors. And this is a process which takes kiln-dried wood, and then it puts it into another kiln in a vacuum over a 2-3 day period, and it will actually cook the timber to a very, very high temperature, just to the point before combustion, and hopefully it won't catch fire. And after that process, the result will be a dark brown wood where the cells inside the timber have actually collapsed, where there's about 3% moisture content, something like that. And what it means is that you can take a species of hardwood or softwood that cannot be used outdoors, and you use this process, and then you can take it and use it outdoors, because it improves dimensional stability, it removes all the food, it will repel moisture. Now, there are many, there's no real generic process to this. It's, these are many companies who have developed their own technology, but it's more or less based on the same thing. There is some chemical modification as well. There is Accoya and Kebony, which they actually use chemicals to modify the wood to make them suitable for outdoors. But here we're talking about thermal modification. It all comes under the Thermo Wood Association, which is based in Dresden in Germany. And then there are various brands like Cambia Wood, Thermery, Nova Wood, Tan Timber, Viking Wood. These are all products that come out of it. When we're talking about American hardwoods, it's most suitable for red oak, for ash, for tulip wood, for soft maple, and for birch as well. But really, it works best of all. Really works best of all with red oak, with ash, and with tulip wood. And it's really amazing because here you have, for example, in the case of tulip wood, you have a species that's quite soft, that there's absolutely no way you would use it outdoors. And now you can use it as cladding on the outside of a building and it will last many, many, many years. Or with red oak, again, you would never use that outdoors for decking or for furniture, but then through this process, you can now also use that outdoors as well with some confidence. And the other thing that's really good about this is it means that American hardwoods with proven legality and proven sustainability can be used outdoors instead of using a hardwood from West Africa or South America or Southeast Asia, for example. So this is also a very, very good environmental choice. Here is an example in Australia. This is in Melbourne. It's a cafe restaurant at the airport, at one of the airports. And this is all thermally modified tulip wood. This is very fresh as well. This has just been done. And by now, this picture was taken about 3 years ago. By now, it will all be a silver gray color because wood naturally, when it's exposed to ultraviolet light, will fade, which is also part of the appeal. Melbourne has a huge amount of rain and a huge amount of sunshine. So it's a really quite a challenging environment to use wood outdoors, but here it's being used in a nice public application. And here's another project in Melbourne. This is tulip wood that's been thermally modified. And not just that, but it's also been stained black, which is really interesting because when you stain timber black, you're actually attracting more heat to the wood. So you're putting it under even more pressure. But this is holding up very well. This is a private house just near the beach in Melbourne. So it's also being subjected to sea air, and salt, and wind, and lots of rain and lots of sunshine as well. And this is a project that we did 2 years ago in Australia, in Melbourne, with a well-known Australian architect and furniture designer, Adam Markowitz. And here we designed a piece of furniture, if you like, a large piece of furniture, which was made of natural red oak and thermally modified red oak. And it was because, in particular in Australia, red oak is not really known, it's not really appreciated. So we wanted to show the incredible versatility of this species. And those fins on the outside of the stand, which is the darker brown color, those are thermally modified red oak, everything else is natural. And all of this wood has been repurposed for other projects afterwards. And that's also something that we like to do. If we do an installation somewhere, either it becomes permanent or we reuse it or repurpose it into something else. Here's a project that we assisted with. It's not our project, but we assisted with it. So this is Lord's Cricket Ground in London, very famous cricket stadium in Marylebone in London. And the new Warner stand, which is the main stand at one end of the stadium, they wanted to build a cantilever roof to shade and shelter all of the spectators. And they wanted to use wooden beams to cantilever that roof. And the architects, Populous, they came to us and they said, can we do this with oak? And it was very interesting because it was a really challenging thing to do. And they ended up using American white oak to make these glue laminated beams. They're the longest glue lam hardwood beams in the world. And I'm not sure how long they are, but they're extremely long beams. The wonderful thing about white oak is it's incredibly strong, and also it has natural durability. So being outdoors in London is going to be okay. This technology we're looking at furthermore. At the moment, we're doing a project with Cambridge University. We're looking at the possibilities of glue laminated red oak. And also there is a company that we're working with in Australia, in Melbourne, that is also exploring the possibilities of using American red oak in structural beams as well. And here's an interesting project. This is at a hospital near Manchester in England. It's a Maggie's Centre, which is it's a centre where recently diagnosed cancer patients get taken. And the architect, Alex de Rijker, he had a personal connection to this because of his wife. But the whole purpose behind this design was to make something that was as natural, as warm, as welcoming as possible for somebody who had just been diagnosed with cancer. So he decided that he was going to make the entire building out of wood. Everything is made out of wood. So this is actually a cross-laminated timber box, so CLT box, but it's unique because it's cross-laminated tulip wood, not spruce or pine, which is normally used to make cross-laminated timber. And then the entire thing has also been clad on the outside in thermally modified tulip wood. So it's a complete tulip wood box. Hopefully I can get the video played so you can see inside it as well. What's wonderful about using cross-laminated tulip wood is that they've left the inside walls unfinished, so you can see the tulip wood. So it's a structural panel and a decorative panel. Here's another project in cross-laminated tulip wood. This is back in 2016 with Alison Brooks in London. Here we were really looking at what you could do with tulip wood to make cross-laminated timber panels. Now, when you use spruce or pine, which is what's normally used, the reason it's chosen, number one, is because it's low cost. It's widely abundant, low cost. So to make a wooden panel, to end up making a wooden building using cross-laminated timber from spruce, it can also be a low-cost option. Now, here we are introducing a hardwood, we're introducing tulip wood. So it is naturally going to be more expensive than the softwood. But there's a major advantage. It is 3 times stronger in rolling shear than spruce. So it means that you need less layers to make a structural panel which has the same strength. So where you might need 5 or 7 layers for spruce, you will only need 3 or 5 layers for a hardwood CLT panel. This particular project called The Smile in London, which was there for London Design Festival, was an enormous box which had a lot of load from the wind on one side of it. And it was extremely strong. So we worked very closely with Arup, timber engineers. We did a lot of studies, and it was an incredibly successful project. The sad thing is, at the end of London Design Festival, we couldn't move it anywhere. So we had to destroy it. But the good news is that it was used to generate electricity for 80 houses for a year. And here is another tulip wood CLT project. This actually is the second incarnation of Multiply, which was designed by War Thistleton Architects. You perhaps have heard of Andrew War, who's really championing the use of timber in building in the UK in particular. And this was exploring a possible solution for low-cost housing using hardwood CLT. And this was reconfigured for Milan after London Design Festival, then it was reconfigured for Madrid, and then it was reconfigured again and again and again. So these boxes are being repurposed all over the world. So we've looked at provenance, we've looked at legality, we've looked at sustainability, we've looked at who owns the forest and why this is important, the legality of harvest, growth versus removals, we've looked at life cycle assessment, and finally the American Hardwood environmental profile. We've looked at the species mix in the forest, at kiln drying. We've had a closer look at some of the key species and their applications, and a look at suitability for flooring as well. And then we've looked at some newer technologies, new applications, wood modification, which is opening up new possibilities, in particular thermally modified timber, cross-laminated timber, and also glue-laminated timber. And with that, I think I've reached the end of my slides. So I appreciate very much everybody listening, and I think I need to stop sharing my screen.
Okay, thank you very much, Rod. Thank you.
Thank you. Now I'm just not sure how to do that. I think it's this one. Is that correct?
Yes, thank you very much.
Yeah.
And now, I think you are still sharing your screen, or again, I don't know.
There we go.
No, it's okay. Okay, thank you.
Okay, good.
So then we can go over to the questions. Dear lecturers, dear students, please raise your hands, or you can write also in the chat box your questions if you don't have any microphone or whatever. So ask please your questions. And during we are waiting because the students they need a little bit more time sometimes. So to think about the question. Already a hand is right. Afaf Ali Ömer. Yes, you can ask your question, Afaf.
Hi, good evening, everyone. Thank you, Mr. Wiles, for this lecture regarding the woods and cross-laminated timber. I have one question. I don't know if it's related to your path or study or field of your study, but it's one-sided study, like a research regarding cross-laminated timber using in a certain project. And while I'm doing this research, I found very interesting point. They said while they are cutting the trees, they are using high-tech technology of cutting the trees, which very good technology that has like a benefit, not harming the forest. Actually, I didn't find more information related. So if you can provide anything related to this point, I'll be very thankful. Thank you.
Sure, thank you. Thank you for your question. I mean, I'm not an expert in cutting trees, but I know something about it, and I've seen it done a fair bit in different countries. The modern way of felling trees is by using a giant machine that's basically a tractor with a big arm on the front that grabs hold of the tree, chops the tree at the bottom, takes the bark off, and chops it into the right length of log. And that can be done in a way that really has minimal disturbance with the other trees around it, particularly when it's a well-managed forest, so there is some space between the trees. But of course, with some species, in particular with softwoods, which are normally used in cross-laminated timber, the normal way of cutting trees is actually to fell all of them in a particular area. So it's what's called clear cutting. Now, this is a very ugly process, but it's not necessarily a bad thing, because all those trees have been planted, they've grown at the same height, the same rate, so they all need to come away and then be replanted again. With hardwoods, it's different. We're talking about a natural forest, trees at different heights, different ages, different species, so you can never clear cut. But rest assured that the way felling is done nowadays, at least in North America and in Europe, is done with as little disturbance as possible to all of the other trees around.
Thank you very much.
Thank you. There is a question in the chat box from Dalia Sama.
Oh, okay, regarding the flammability of wood. Would it be a hazard? Okay, so this is also a very interesting question. Now, wood burns, yes, but everything burns if the temperature is right. The wonderful thing about wood is that we know exactly how quickly it burns. So when we design something out of wood, we already know at what rate it will burn, the charring rate it's called. So if you're going to build something with wooden beams and you're worried about that building burning down, actually what's interesting is the wood will burn from the outside. It will create a layer of charcoal, a layer of char, the black stuff that we use on the barbecue. And once that layer gets to a certain thickness, it will stop burning inside because it will actually insulate the rest of the beam. But what's really interesting is it does not change the structural integrity of that beam. Whereas if you put a lot of heat on concrete or a lot of heat on steel, it will actually change the structural integrity of a beam, for example. Concrete and steel, the steel will twist, will melt, will change shape, whereas the wood will not change shape. So what we do with wooden beams is we generally over-design, we over-engineer, we use a little bit more wood than we would normally need. This is why we're able to produce things like fire doors, fire-rated doors, where we can say, oh, well, this is a fire-rated door rated at 2 minutes or 5 minutes, because we know how long it will take for a flame to get through from one side to the other side. Of course, the other thing about wood is you can treat it with fire retardant. So you can actually prevent it from catching fire in the first place by using chemicals on it as well.
Dear students, do you have other questions? You can raise your hand. Okay, I can ask a question. Thermowood and use in structural members. Because I don't know, the last information I had, if you create thermowood, you cannot use it for the structural members. Is it still this information, or is there any advanced technologies now?
I would say this is something that is being researched at the moment. But on the whole, when you put wood through the thermal modification process, you make it more brittle, so it will break more easily. So you make it harder, you give it better dimensional stability, so it won't move so much, but you also make it more easily breakable. So it changes the structural integrity of the wood. However, we are exploring thermally modified tulip wood cross-laminated timber and a few other things. So I think certain structural applications, the answer will be yes, it's possible. But these are applications that don't have a lot of load. So it could be something like a shade structure, a pergola, a carport, a climbing frame, for example, things like this that are not actually going to be big buildings with multi-floors, But the research is ongoing.
Okay, thank you very much. Dear lecturers, dear students, do you have more questions? Nilay Hocam.
Thank you very much. First of all, thank you very much for this stimulating lecture. It had been great, I think, for all of us, for students, and also for us as instructors. I have a question about the workmanship. I think this requires specialized constructors, right? Because the examples we have seen had very good finishes and the workmanship seemed great. I believe that might be one of the obstacles, for instance, for the case of Turkey. I think, do you think that such a specialization is required, or, you know, how do you foresee it for countries like Turkey? I mean, where the use of wood, especially CLT, is not very common.
Well, it's a very good question. The short answer to that is that there are highly skilled woodworkers in Turkey who are more than capable of making really high quality things. I know, I've seen it with my own eyes. If you're familiar with Baku, Azerbaijan, there's the Heydar Aliyev Cultural Center designed by Zaha Hadid, that extraordinary building. And inside the main auditorium of that building, it's all American white oak, the auditorium. And it was absolutely beautifully made, and it was made by a company in Ankara. And it's wood suspended from the concrete shell of this building, and it's tens of thousands of individual pieces of oak all glued together in a beautiful form. The workmanship on this was world class. I've also seen other projects, actually another one in Baku. It was the airport terminal in Baku airport. Again, it's white oak and Turkish contractor, Turkish designer. This was Otoban designed it. I'm not sure who the contractor was, but I met one of them. Again, the workmanship was superb. When it comes to CLT, there are actually some Turkish companies who are specializing in cross-laminated timber. So again, the knowledge is there, the know-how is there. I have no doubt that over time, you know, these skills will improve and get better. But as of now, there is no reason to suggest that people in Turkey are, you know, won't be able to work at the same level as any of these projects that we've seen. And in fact, one thing I would like to do in the near future is to work on a project in Turkey with designers and architects, more than one project, do a collaboration with American Hardwoods. So where we would need to work with good designers and also good manufacturers. And I don't think it'll be difficult to find them.
Thank you very much.
Thank you. I think there's another.
No, I think this is Nilay Hoca. Dear lecturers, dear students, do you have questions? Demet Hanım, do you have additions?
Oh, I almost would like to say many thanks to Rod for the impressive and informative presentation, because we had learned more about timber spaces and projects around the world, all around the world. Thank you, Rod. I know some of them, many of them, but again, it's a good summarize for me and a good presentation for all audience and students, I think.
I really appreciate the opportunity. Thank you. I sincerely appreciate the opportunity to do this, and I really mean it when I say that in the very near future, we would like to work on some collaborative projects in Turkey with established designers and also with design students. You know, I think there are tremendous opportunities to improve the knowledge of wood and working with wood and specifying wood in Turkey, and I hope that in the next few years we'll be able to do that together. So I look forward to it.
I hope so. I hope.
Mr. Wiles, we have another question. Our lecturer, Göksun Akyürek.
Hello, everyone. Thank you very much, Mr. Wiles, for the presentation. Actually, we have been listening to, this is our fourth lecture on wood, and I'm very convinced that our future lies in this, you know, construction technology. And I wonder, is it, or I wonder about the future perspective of this material and technology. Will it be more accessible for, I don't know, middle class people? Will we be able to live in, you know, I don't know, engineered wood or CLT houses in Istanbul, for instance? Do you have such a perspective? Is it too futuristic, or I'm really jealous because I really would like to live, you know, I hope that it's not so exclusive or so, you know, expansive. So is there any such vision or perspective? Do you see it coming?
I do. It's a good question, and the answer is it's not more expensive. It's actually often cheaper, and that's because the wonderful thing about building a building out of wood, whether it's cross-laminated timber or glulam, is that much of the work can be done in the factory, and then it's brought to the site. So you don't have weeks of heavy foundations and people on site pouring concrete and using reinforced steel. That none of that is needed. You know, you can make a very thin foundation, and then you have all of the components are pre-made in the factory. They're brought to the site. They're put together in a very short amount of time. So again, it's the amount of time that is needed to build the building. Time equals money. So it can be done very cost effectively, as long as the material and the technology and the knowledge is accessible to everybody. And that's what's going to have to change and improve. At the moment, everybody can build with concrete. Not everybody can build with timber. And so that's something that will need to improve over time. But it will come. But a lot of it will depend upon the flexibility of, for example, in Istanbul, the flexibility of the, what do you call it? The municipality, the council, with building regulations, you know, what can and can't be done. And, you know, that's also a big obstacle. And that's something that we're facing in many countries around the world. In the UK, which is where I'm from, there are some multi-story wooden buildings, but there's also a lot of resistance to doing it. And it's usually for the wrong reasons. But again, it's regulations, you know, these are things we need to change. If all of those regulations are flexible and open, if there are more people who know how to do it, then it should be cheaper. It just will take time to get there.
Yes, thank you very much.
Thank you, Göksun Hocam.
No question, I think.
I don't know. I just wait a second, and I'm going to check the chat box. So on last minute. Okay, if there are no questions, just one sentence on my side. So we want to thank you for the very informative presentation, Mr. Wiles, and talk. We have a tradition in ArchiDesign talks of BAU Faculty of Architecture and Design. A donation has been made in your name to SAVE Foundation, helping underprivileged children for equality in education. So,
fantastic.
Thank you very much.
That's excellent. Thank you.
Thank you, Rod. Thank you very
so much. I hope this was really useful and informative. And once again, I really appreciate the opportunity to take part today. And I hope to see you all again and meet you in person.
Okay. Thank you very much.
Thank you.
Thank you.
Thank you very much.
Bye-bye.
Bye-bye.